Hi, this is going to be a video about how to set up a hot start PCR. And PCR stands for polymerase chain reaction. This is a way of making a DNA strand from another DNA sequence. And if you haven't done PCR before, you can look up more information about that. But just briefly, PCR is used to generate or to amplify a fragment of DNA from some kind of template. And we use this as the first step to making double-stranded RNA for RNAi and to generate riboprobes for in situ hybridization. That's the main two reasons you'll use hot start PCR in this lab, though it can be used for other things too. And a PCR at its very most basic is always going to involve a DNA polymerase. In this case, we'll use Taq polymerase. It's going to use dNTPs, so dATP, dTTP, dCTP, and dGTP. It's going to use a primer, which is a short sequence. It's going to specifically bind to the region that's to be amplified and get the process started. DNA polymerase can't just start on its own. And there's also going to be some kind of buffer component in any PCR. So this hot start PCR protocol that's going to follow is one type of PCR, although there are many others. And the reason we use hot start PCR is that this specific protocol is okay to set up on your bench just at room temperature. So it's very easy when you're just starting out. Sometimes people aren't quite as quick. And so this is a pretty robust protocol for us to use for our purposes. So the methods that we use can be found in the protocol, and I'll go through the protocol in the next several minutes of this video. Hello, this is a video that we're making about how to set up PCRs. And the protocol that I'll be using for this PCR is this one, Amplifying with PCR. This is a hot start approach. And some of you may have done PCRs before in other labs or in your past lab experience. But what this hot start version allows you to do is set this PCR up on your benchtop without having the polymerization start until you put the reactions in the thermocycler. So what you're going to notice is that in the first few steps of this reaction, you precipitate the magnesium ion out, and then that ion is released in the first step of the PCR, okay? So I am setting up a series of PCRs that all have the same template. And so I have used this hot start template and protocol to go ahead and fill out my lab notebook. So you can see I've written out what I'm gonna do and how I'm gonna set up my reactions. So you can do that before you start. I'm also filming this during the coronavirus pandemic, so that's why I have the mask on, just in case in a few years people are confused about what I'm doing. And what I'm going to do today is set up a PCR in order to make double-stranded RNA. And so most of our clones that we use in the lab are in the PJC 53.2 backbone, and they have a gene of interest cloned into them. And this gene of interest has on each side sites that are promoters for RNA polymerases T7, T3 on one side and T7, Sp6 on the other side. So what we're going to do in this PCR is take this circular plasmid and use a primer that matches the T7 polymerase sites on each side and generate a PCR product that has our gene of interest flanked by the T3 and T7 promoter sequences on one side and the Sp6 and T7 promoter sequences on the other side. So in this protocol, the first step is going to be that we're going to make a few of our reagents. I'm going to make sure I have everything, and you can do this, and then if you were using this video along with setting up reactions, you can pause and make sure you have everything. And so the things that I have are, I have a tube of 35 millimolar magnesium chloride. Magnesium is a really important ion for a lot of different enzymes, and it's a necessary factor for the polymerase that we're going to use in this reaction. If you didn't have 35 millimolar magnesium chloride, you could generate that from either a 50 millimolar stock or a 1 molar stock. I also have a tube of DNTPs. These are 10 millimolar, and this is a stock that we have aliquots of in the freezer. The other things I'm going to need are my primer. This is a T7 primer. Like I mentioned, it binds to the T7 promoter that's used by the T7 polymerase. And so one mistake that very commonly happens in the lab is that people will use the T7 enzyme or the polymerase when they mean to use the T7 primer. So just make sure that whenever you're getting out the primer, it should be frozen and it should say T7 primer or T7 PR on the lid. If you get something out of the freezer box and it's not frozen, you may have pulled out the T7 polymerase by mistake. And so I have a little bit of this primer left, but I don't have a lot, so I'm going to make a little bit more of that by diluting 100 micromolar stock, 1 to 10. The other thing I'm going to need to do is take my template, and I'm just using one template for all of my reactions, but you may have many different templates. And for each template, you need to make a 1 to 15 or 1 to 30 dilution in water. And the reason is that you don't, whenever we have a plasma that's a mini prep, the concentration is very high, and PCR doesn't require very much. So you're going to make a dilution. So I'm going to make a 1 to 15 dilution of my plasmid. And then we are going to talk about the next steps, which are to make the hot start buffer and the hot start mix. So you could go ahead and label your tubes hot start buffer or hot start HSBF and HS mix. The other thing we're going to do later is to create a master mix, so I always label these tubes MM. And a master mix is just when you combine all of the components of a reaction, except often you'll combine everything except the template, and you can pipette your mix instead of having to pipette all of the different reactions many times. And this will save you time and also decrease the likelihood of making a pipetting error. So we're going to use a master mix today. So I'm going to stop this and have a pause. I'm going to make my primer dilution and my template dilution, and then we're going to come back and make the hot start buffer and the hot start mix together. Okay, so the next things we're going to do are to make our hot start buffer and our hot start mix. I also wanted to mention that I had forgotten to get out one thing, that is 1 molar ammonium sulfate. We have stocks of this in the freezer, and so if you're watching through this whole video before you start, you can get this out at the same time as the other materials. The other thing I wanted to mention is that you'll need a set of PCR tubes. So PCR tubes are these small tubes, whereas I usually call these 1.5 ml tubes. And these are the tubes in which we're going to set up the PCRs. So when you're setting up PCRs, you always want to label your tubes. What can happen is different people can be running PCRs at the same time, and you don't want to get your tubes confused. I'm doing something a little bit different because all of my reactions have the same template. So I've just numbered the end, each end, and I've put my initials and date on them. If you had a lot of different things, you probably want to label each tube, or at least label them in enough detail that you can tell what they are. There's not much room on these, so you can't necessarily label the full information, the number and the template and everything. So that's where in your lab notebook you need to make things really clear. Okay, so if you haven't labeled your tubes or gotten them out, you can pause here and do that and then come back to the video. Okay, so the first thing we're going to make is the hot start buffer. This is a buffer that can probably be frozen and thawed once, so if you've done this before and come back to it, you can use the same one. But I make the hot start mix fresh every time, and that seems to make the PCRs work better. So in the hot start buffer, I'm just making one volume of it, just in the way that it shows in the protocol. So here it's shown right here, but I've also copied this into my lab notebook page up here. And so I'm going to combine in one of these 1.5 ml tubes 100 microliters of 1 molar tris at pH 9.5. Be careful with that pH. We often have more than one tris buffer around in the lab, and so you want to make sure to use the alkaline one. I'm also going to add 20 microliters of 10% tween. Tween is a detergent. And I'm going to add 80 microliters of water. And that water needs to be sterile water, so you don't want to just get water out of the sink or anything like that. You can autoclave water to have it sterilized, or you can sterile filter it. And so I'm going to make, I think, a few tips and tricks videos, and you can look at those to find how to sterilize things, or you can talk to other people in the lab. Okay, so first I'm going to use my pipettes. I'm going to use, for this whole PCR and all of the steps that follow up until I tell you, you can just use the regular tips. You don't need to use the filter tips that we use for RNA work. And that's because DNA is really stable. You don't have to take all the extra precautions for DNA that you do for RNA. So I'm going to pipette 100 microliters of tris pH 9.5. I have a bottle of that here. I'm going to be careful not to contaminate my bottle when I'm pipetting. I'm going to pipette that into the tube, and I like to pipette down into the bottom of the tube, that way it doesn't splash out. Okay, and then I'm going to discard my tips. In our lab, we tend not to put tips in the trash can because those tips are sharp and they can puncture the bag and then cause the bag to rupture or poke somebody. So we usually I keep like a tip jar and then put those into the plastic base. That'll be true for all the tips you use. Okay, next I'm going to use a different pipette to pipette 20 microliters of the 10% tween, and I have some of that here. Lastly, I'm going to pipette 80 microliters of sterile water. Okay, now you'll have these three things in a tube. I'm just going to flick the tube to mix them. You often don't want to vortex to mix when you have a detergent, because that will make it just super duper bubbly. Okay, so the hot start mix is the major component of the hot start buffer, is the main component of the hot start mix. So I'm next going to make the hot start mix in a second 1.5 ml tube. I'm going to pipette first 167 microliters of the hot start buffer into that tube. And you want to think about, if you're doing a whole lot of reactions, you may need more than 200 microliters of the hot start mix, and you can just double both the hot start buffer and the hot start mix if you need to do that. So I'm pipetting the hot start buffer into my hot start mix tube, just like so. The second component is 32 microliters of the ammonium sulfate, which I mentioned we have as stock solutions in the freezer. And that's thawed out, so I can pipette that. And I like to pipette this directly into the other liquid. That way it doesn't splash out. I make sure things are mixed. And the last thing that we need for this is in a different spot. And so we need 1 microliter of phosphoric acid. So I'm going to take my tips and my pipetter and my hot start mix tube, and you are going to come with me into the other room. So phosphoric acid is an acid, so we have to keep that bottle in the acid cabinet. And our acid cabinet is over here, and there is an acid cabinet at the bottom. So that's where the phosphoric acid is going to be. Never taken a phone into the acid cabinet before, so this will be kind of an experiment. That's one of those do as I say. So I'm going to add 1 microliter of the phosphoric acid It's under the cabinet, so I'm gonna bring this out and I'm going to put it in the cabinet so I can pipette it. I apologize for the noise, this is kind of loud in here. And I'm going to pipette, this is a pretty full bottle, so I'm going to take my clean pipette tip and angle it so that I can see the tip going into the liquid. If you put this too far in, you're going to get acid all over your pipette, which is not great. And then I'm going to pipette this 1 microliter into my tube. Okay. Hope that wasn't too noisy in there. Taking you with me back to my bench. Okay. So now we have both our hot start buffer, which we're pretty much done with. You can throw that out. If you'd made, twice as much so that you could use it twice, you can keep it in the freezer. And now we have our hot start mix tube. So what we're going to do is add, as the protocol says, 5 microliters of the hot start mix into each tube and 5 microliters of the 35 millimolar MgCl2 or magnesium chloride. And so what I like to do is set my pipette to 5 microliters. And what I'm going to do is I'm going to pipette one of these solutions onto one side of the tube and then the other solution onto the other side. And then I'm going to flick them down to mix them at the end. So I'm going to start with the magnesium chloride. As I said, I'm going to pipette these kind of against the side of the tube. And that's going to be that. So I'm going to pipette this magnesium chloride 5 microliters onto my left side of these tubes. And I'm right-handed, so that's the angle that works for me, but you might do this opposite if you're left-handed. The thing is, you don't want to mix the two. And the reason I pipette them the way I do is because then I can just use one tip over and over so that I waste less material. Okay, so I've added my 5 microliters of magnesium chloride to each tube, and I'm going to rotate these tubes 180 degrees. So now the little beads of magnesium chloride are on my right hand side. And now I can take this hot start mix and pipette it onto my left hand side, which is now vacant. And this way, like I said, you can just use one tip. The other thing is we very often only use the hot start mix one time. And so if you're going to throw this tube away, it's okay if you contaminate it with a little bit of the magnesium chloride, but you don't want to do things in the opposite order. Okay, so because I've put these, I'm going to get rid of my tip, and then again this I'm not going to use again, so I'm going to throw it in the trash. So if I show you this, you can see that there are little beads of the magnesium chloride and the hot start mix. Some of them have made their way to the bottom of the tube, but some are still on the side. So I'm just going to gently flick them like this, and then both of the little beads of liquid will go to the bottom. Okay, I'm going to do that with each of my rows of tubes. Okay, and so there you have both the hot start mix and the magnesium chloride at the bottom, and they are going to precipitate. We're going to give them 15 minutes. So I'm not going to just sit here and bore you for 15 minutes. I'm going to stop the video. You can pause the video if you want. But one thing we will do before the end of the 15 minutes is set up the master mix, which is all of the reagents that are going to go into the next step. So what I would say is go ahead and make sure that you have everything out that you're going to need for the master mix in this 15-minute period. So that's your template that you diluted, your T7 primer that you may have had to either make more or make sure you have enough, your DNTP mix, and water, sterile water. TAC is the polymerase, and that's the enzyme that's going to catalyze this reaction. We never want to get out an enzyme until we're ready to use it. So we're going to go together and get the TAC polymerase when we're ready for that step. We're not going to get it out, early. It doesn't need to thaw or anything. So we'll get that out when we're making the master mix. So if you were doing this yourself, you can set a timer. I always count up. And so once 15 minutes has passed, or once you're at maybe 11 or 12 minutes, you can go ahead and start making your master mix, and then we'll add that to our tubes. I will say that I'm making my master mix a little bit different. I'm adding the template in because all of my reactions are the same. If you were setting up 10 different PCRs, for example, with different templates, your master mix would include everything but the template. You'd add the template in last, and then you would set your PCRs up. So we'll go over that again in a second when we come back. All right, so the next step we're gonna have is to set up our master mix. The protocol has a list of all the components you're going to need. And to set up a master mix, what you'll do is to, copy this over onto your lab notebook page and multiply the ingredients that are below this dotted line by the number of reactions you have plus a little. So for example, I have 20 reactions, but I'm multiplying these things by 22. That way there's a little overage. What will happen if you don't do that is that you'll run out. You'll be a couple of microliters short. So as I mentioned, I'm setting up a bunch of reactions that are all the same. So I'm actually going to add my template to the master mix, but typically this is not what you'll do. So what you'll typically do is set up a master mix for all of your tubes. And if you have many different templates, you're going to leave out the template of your master mix. So you're just going to have everything else here. The other thing I wanted to mention is that this protocol has forward primer and reverse primer separate, so 2 microliters of each. If you have a reaction where you're using a different forward and reverse primer, that's what you'll do. But as I mentioned, for this plasmid, we're going to use the same primer for the forward and reverse. Both of these match this T7 promoter in the background of this plasmid. So because we're using the same primer for both forward and reverse, I'm just, when I'm setting up the reaction, I'm going to add 4 microliters of this T7 primer instead of 2 of each. Okay, and then you have the DNTPs and TAC polymerase. A lot of times you'll have a reaction set up like this, and you may not add the materials in the same order that is seen here. So what I would do for this is to add the water first. So in this case, I'm going to add 715 microliters of the sterile water. Sorry, I'm all over the place here. So 715 microliters of sterile water, and this goes into my master mix tube. So I'm adding the water first. Next, after this, I'm going to do things in the order that they're listed, and almost all of the time, there's a couple of examples that will not be this way, but most of the time, you're going to add the enzyme last. So I'm going to add everything but the enzyme, and then we'll do that last. So the second thing I'm going to add is the template. Sorry, just one second. So I've added the water. The second thing I'm going to add is the template. So for me, that's 22 microliters. The volumes that I'm saying for this may not be the same as for you, because I'm doing 20 reactions. You might have 10 or you might have 80. But the second thing I'm going to add is the template. Again, I'm pipetting into the water for each one so that I know that I'm not losing that by spraying it or dropping it somewhere else. The next thing I'm going to add is the T7 primer. And then I'm going to add the DNTP mix. And this DNTP's mixture has DATP, DGTP, DCTP, and DTTP. That's why we call it, sometimes I'll call it a DNTP mix. It has all of the deoxyribonucleotides that you need for a PCR, or that you would need for generating DNA. So I'm going to mix all this stuff together. You can just kind of flick or invert the tube a couple of times to mix. So the last thing I have is the Taq polymerase. As I mentioned, we are going to add the enzyme last. So I'll take you with me. Enzymes are proteins, and proteins can be damaged if they warm up and cool off too many times. So when you get an enzyme out for any of the things that you do in the lab, you're going to come over to the freezer, and you'll see it here. There are these little cold blocks like this, and you are going to get the enzyme out and put it on the block, just like that. And try not to stay in the freezer too long, so if you're not sure what you're looking for the first time, get help. So I'm going to take this Taq polymerase. It says TAQ. This is a DNA polymerase that is really high processivity, so that means it makes DNA very efficiently. I'm taking this back to my bench. Set you back down. And I'm going to pipette this into my master mix. And again, if you have several templates, you're going to do all of this except adding the templates. So you would do that. You know, each tube needs to have one template, not a whole bunch. So I'll kind of go over that in a second. So I'm adding my enzyme into the tube. You'll notice that this liquid is a little bit more viscous. You might see like a little swirling in there. That's because most enzymes are in glycerol to stabilize them. And I'm just inverting this a little bit. Okay, now before I set up my PCRs, I'm going to take my enzyme back, and then I'll come back and set up the PCRs. Okay, so as you noticed, I only took the enzyme out right when I needed it, and then I put it back into the freezer right afterward. What this allows us to do is keep these enzymes working really well, so that the next time someone else goes to set up a PCR, their PCR is just going to work just as well as yours. So now I have my master mix tube that has all of my reagents in it. If you're leaving out your template, it would have all the reagents except for that. And I'm going to pipette it into each of my PCR tubes. At this point, I'm not entirely sure you'll be able to see it, but you might be able to see it a little bit. There should be a white precipitate in the bottom of each one of these tubes. And at this point, I'm to the 15-minute point. This is the magnesium chloride that's been precipitated out by the combination with the hot start mix. And this will stay a precipitate until the thermocycler reaches 95 degrees. That will resuspend the magnesium chloride and allow the reaction to proceed. So this is a little bit different than other PCR methods that are not hot start based. So for this, I'm going to add 40 microliters of my master mix to each tube. If you've left out your template, you're going to add 39 microliters to each tube. So I'm just going to go ahead and pipette that. And I'm using the same pipette tip for all of this. I'm not going to reuse this master mix, so it's okay. You know that this might be kind of touching the side of the tube. I will say that I'm not putting this all the way down in the tube. I'm just pipetting against the wall. And then the reactions will look kind of like this. If you had any, let's see if I have any with a bubble in it. There's some with bubbles at the top. Occasionally there will be a bubble at the bottom, and I'll tell you what to do about that. Okay, so if you have not included your template in your master mix, once you've added your master mix to your tubes, then you're going to add 1 microliter of your 1 to 15 template to each tube. So if you had 10 different templates, you'd add 1 microliter of template 1 to tube 1, and 1 microliter of template 2 to tube 2, and so on. Make sure that in your lab notebook you have really good notes. You don't want to mix things up or have reactions and not know what template belongs to what tube. Okay, and again, I'm not adding the template because I added that into my master mix, but if you were doing that, you would do it here. 1 microliter of your 1 to 15 template into each tube. I'm putting the lids, which look like this, onto each tube, and I like these strip tubes just because they're more convenient. So your tubes will look like this. You may need to flick them. Again, sometimes there's a little bit of a bubble at the bottom and you don't want to have that going on. And then you're going to take your tubes into the other room. So I will take you with me. The other side of the lab, in the back of the lab, there are 2 PCR machines or thermocyclers. They look like this. Often we'll ask that you put a little bit of a tape or post-it note or something like that onto a machine when you're using them. In this case, Tulip's using this one. I'm going to use this one. You want to use one where there's a green light here. So I'm going to open up this part of the machine and put my tubes in here. So it looks like this. And I'm going to close the lid and bring this arm down. And that just makes sure the lid of the PCR machine is tight to your tubes. Next, let's see if we can find the label here. There's a selection here, programs, and you'll see several different programs here, and one of them is called Hot Start 1. And so you want to start Hot Start 1. It will give you options. Whichever ones are available will show up here. So block 64, which is where Tulip samples are right now, is not available, but 32, which is where these samples have been put in, is available. And then left is this bigger machine on the left. You want to use the machine that has the smallest capacity that works for you. So I had 20 reactions which fit into this small block. You don't want to use this 96 tube block if you had 4 reactions or something, because someone else behind you might have a lot more. Once you select, you can use the arrows to select which one you're going to use. So I need block 32. I'm going to hit OK. And this will start my reaction. And so then you'll be able to see that the light's blinking. So on the protocol, it gives you a little bit more information about what this thermocycler program looks like. So let's come over here. So on this protocol, it says that the recommended program here is shown here. So first, it will heat to 95 degrees for 5 minutes. That will resuspend that magnesium chloride precipitate that I showed you. Then it will do a series of 95 degree, 55 degree, and 72 degree steps. This is the melting. This will melt the 2 strands of DNA apart. Cooling to 55 will allow the 2 strands to come back together, or rather the primers to bind to the template, and then which is called the annealing temperature. And then the reaction will be heated to 72 degrees, which will allow the polymerase to do its job. And then step 5 will be to go back to 2. So the machine will go 2, 3, 4, 2, 3, 4, 2, 3, 4. And that's that polymerase chain reaction going over and over again to amplify the insert from our plasmid of interest. And then at the end, you can see that there is a 72-degree step that just makes sure that all of the product of the PCR is complete and has those ends. And then it will cool to 4 degrees for storage. So if you wanted to set up this reaction one day and come in the next day to tend to it, that's like putting it in the fridge at the end. So at the end of this, we will have a PCR product that has this gene of interest with the T3 and T7 polymerase sites on one end and the Sp6 and the T7 sites on the other end. But that is about it. I had put away the Taq polymerase right after I used it, but I have some of my other reagents. Those are going to go in my freezer box at minus 20 degrees, which is just a regular freezer. And then I'm going to go label that PCR machine with my name so that people know that those are my samples. The reason that can be important is that it might be that, say you set up reactions and you leave for the day or go on to do something else, your reactions might finish and someone else might need to use that block. And so if there's a piece of tape saying, Rachel, hot start, then if someone needs to move my samples into the actual fridge, they can take that tape or label and move it with my samples. That way, we don't get a miscommunication or samples lost if someone needs the machine. So that is pretty much, that takes us through the amplifying with PCR protocol.